So here we're going to take a look at two examples that are still in intercept form, even though they don't quite look like it. In the case of this first one, we see this x minus 4 squared. Now, in that format, it almost looks more like it's in vertex form than it is in intercept form, and we could view it that way. Or we could view it as 1 times x minus 4 times x minus 4. If I write it in this expanded format, we can see that our a value is 1, and then we can set our parentheses, what's inside the parentheses, equal to 0, and it's just that we have the same thing twice. So what this means is our vertex is going to be on the x-axis. And so if we add 4 to finish this out, we get x equals 4. So our x-intercept is 4, 0. My axis of symmetry, so I can go to 4, 0, make a dot. My axis of symmetry is going to be right there on that line, or on that dot, because we don't have a second 0 to find the average of. It's the same number twice, so that means my line of symmetry is going to be going through that location. So that's going to be x equals 4. And again, my 0 is doubling as my vertex in this case. My x-intercept is doubling as my vertex, so I know my x-coordinate of the vertex in this case. And now I just have to find what the y-coordinate is. Well, I can see it right there. It's 0. So without even having to plug it in, I know what my vertex is. The problem here is I don't have any additional information besides just that one single point. I need to go to the a value out in front, a being 1, meaning that there's no reflection, so my parabola is going to open up, and it's going to be the standard pattern for a parabola because there's no dilation. So that means from this vertex location, I'm going to go to the left and right 1 and up 1. From my vertex, I'm going to go to the left and right 2 and up 4. And then I can do that one more time, left and right 3 and up 9. And so then I've got enough information to be able to sketch my graph. So I'm a little bit limited based on what I'm going to get out of the equation, because everything is all in one place. The x-intercept, the lines of symmetry, the vertex. So I'm going to have to use my knowledge of the pattern of the growth of these parabolas to be able to sketch in the rest of the points. In the second example, it too is written in intercept form, even though it doesn't look like it. So I'm going to rewrite it so it's a little bit more familiar. So I've got this -1 that's out in front. And then for this first x here, we could think of it as x minus 0, or x plus 0 if we want. And then we have x plus 6. So when we see it like this, we can set x minus 0 equal to 0, and x plus 6 equal to 0. And then if we solve each of those mini equations, we're going to get two different x-intercepts. One of them is going to be 0. And then the second one, if I subtract 6 from both sides, I get x equals -6. So if we ever see a lonely x out in front that does not have anything added or subtracted from it, it just means that 0, the origin, is going to be one of our x-intercepts, and then -6, 0 in this case is going to be the second one. So I can go ahead and put those on my graph, 0, 0, and then -6, 0. So right about here. And now I'm going to proceed as usual from the first two examples in the previous video of how to find the axis of symmetry. So I'm going to add those two x-intercepts, 0 and -6, and divide by 2. So 0 plus -6 is -3, or sorry, 0 plus -6 is -6. -6 divided by 2 is -3. So I've got x equals -3, and so I can go ahead and dot that in. And then once again, that doubles as the x-coordinate of my vertex. So now I just need to plug -3 in for x, and then figure out what the y-coordinate is. So I'm going to do f of -3. So here I have to be a little bit careful with my positive and negative signs. I'm going to think of this as -1 times x plus 6. So it's going to be -1 times x, so times -3, and then times -3 plus 6. So I've got -1 times -3 is going to be 3, and then out of this I'm going to get a +3, So I'm getting a positive 3 as an answer, so, or positive 9 as an answer, so my vertex is at negative 3, 9. So I'm going to go up there and make a dot, and now on this one, we've got everything spaced out the way we need it to be able to draw a reasonable sketch of our problem. So in these two examples, even though they don't look like they are written in intercept form, we can adjust how we view them so that we can see that in the top one, we just have the same x value twice, so the vertex is on the x-axis. So that's going to be when we have just x minus 4 squared or x plus 2 squared, something like that. Really, we can almost think of it as being in vertex form. And then in the second one, with this lonely x out in front, it just means that the origin, x equals 0, is going to be one of our x-intercepts.